For years, engineers have been, really pushing the limits on EV performance, but they often hit this kind of wall, right? How do you get more power from a motor that's smaller, lighter, without losing efficiency? Today, we're diving into something pretty groundbreaking, an innovation that seems to have, well, smashed right through that wall. It really looks poised to redefine electric mobility as we know it. We're talking about YASA Axial-Flux motors, a really significant step forward in electric propulsion tech. Our mission here is basically to pull out the key nuggets for you. How are these motors better than the traditional ones? And crucially, what does it mean for the future? For you.
Yeah, it's fascinating, isn't it, how what seems like a simple design change fundamentally can lead to such massive differences in performance. We're shifting from what's usually called a radial-flux design to axial-flux. Think of a traditional motor like a soup can shape where the magnetic push happens around the sides radially. With axial-flux, it's like we've kind of squashed that can flat, almost like a pancake, and the magnetic forces push across the flat faces. Along the axis it spins on. It's really just reorienting that magnetic field, but that simple change unlocks just huge potential.
That pancake analogy is great, really helps visualize it. So, okay, the magnetic field flows parallel to the axle, the axis of rotation, not perpendicular like in, well, most electric motors we see today. But what does that actually mean, for someone driving a car with one, or even just someone interested in where tech is going? How does that squash pancake design translate into benefits we can actually feel or measure?
Great. Right. Well, that parallel flow, it directly helps efficiency, but maybe even more importantly, it lets these motors use much, much larger surfaces inside to generate torque, all within the same sort of volume. You're basically getting more active real estate, you could say, generating that turning force. And that's really the key to why they deliver significantly more power and torque compared to, the conventional radial motors.
Okay, significantly more. Always sounds good. But can you give us a feel for the scale here? Are we talking like a few percent better, or is it a real step change, something revolutionary?
Oh, it's definitely revolutionary. The data we've seen suggests YASA's axial flux motors can deliver up to 4 times the torque and double the power density compared to conventional radial electric motors. 4 times the torque.
4 times. Wow. Okay. That's not incremental. That's a genuine leap. And I imagine that kind of power density, that efficiency, it's not just about going faster, right? It must have physical advantages too. Like a motor that compact must be lighter.
Exactly. Precisely. The design itself allows for a much more compact form factor. It might have a wider diameter, that pancake shape again, but its depth, its thickness along the axis is really remarkably reduced.
Yeah.
And yet that translates directly into saving weight. These motors can be up to 50% lighter than traditional ones.
Half the weight. That sounds incredible. And I think I read somewhere it takes up maybe only a third of the space. Is that right? That just sounds like an engineer's dream come true.
Yeah.
But okay, half the weight, much smaller. Are there trade-offs? Like, is it harder to cool or maybe more expensive to build right now?
That's a really fair point. And yes, initially, manufacturing this unique architecture, it can have its complexities, no doubt. However, the design itself actually offers some inherent advantages that offset that. For instance, the YASA motors, they also use less copper, less iron, fewer permanent magnets overall, which, helps keep production costs down in the long run. And it also lets them get rid of some parts entirely, like the heavy housing around the stator. The stator's the stationary bit inside where the field's generated, making that stator itself something like 80% lighter than traditional ones. So that material efficiency is actually a really crucial part of their advantage. It helps mitigate some of those initial complexities you mentioned.
Got it. So they're clearly high-performance machines, powerful, incredibly compact, and surprisingly material efficient too. Given those kinds of performance numbers, where are we seeing them pop up first? Is it mainly in those super high demand niches?
Yeah, precisely. Yeah, their first home is definitely in the high performance world. Makes sense, right? We're seeing these motors in supercars, hypercars. Brands like Ferrari, Koenigsegg, Mercedes-Benz too, remember their Vision 111 concept car that use them. So it clearly signals their capability for, sporty, high-efficiency applications where power to weight is king.
Yeah, that makes total sense for early adoption, especially hitting those kinds of performance figures. But what about the rest of us, the bigger picture? Are there signs this tech will, trickle down, move beyond those ultra-exclusive cars?
Absolutely. And that's what's really exciting, I think. Beyond those halo cars, Mercedes has already announced pretty concrete plans for mass production. They're planning to use axial flux motors in their upcoming Mercedes AMG.EA electric platform. That's a huge signal. It shows this isn't just staying in the niche, high-end sports car market. It
Hmm.
really seems poised for much wider adoption in regular series production vehicles.
That is fascinating. So if we step back,
Yeah.
that suggests costs will come down, right? The economies of scale kick in. So even though they started out in very exclusive cars, this tech could find its way into a much broader range of vehicles down the line, making that kind of high-performance electric drive maybe more accessible. And it must open up completely new ideas for vehicle design too, surely. I mean, imagine super efficient delivery drones flying longer, or compact robots for tough terrain, or maybe even integrating motors right into the wheels. That could totally reshape car interiors, free up so much space. So pulling this all together, what does it mean for you listening right now? Curious about where things are heading. It means the EVs of tomorrow, maybe even the near future, could be even more powerful than today's, significantly lighter, and offer really flexible designs we haven't even fully imagined yet, pushing beyond current limits. We've seen how this YASA Axial-Flux motor offers this dramatic jump in power to weight. Unprecedented performance in a smaller package, uses materials smarter, and it's making that strategic move from luxury halo cars towards mass production. This tech is really setting new benchmarks. It feels like a shift from niche to mainstream is actually happening.
Yeah, and if we connect it to the bigger picture, what this deep dive really highlights is how these sometimes subtle engineering breakthroughs can just ripple outwards, have massive implications. Which leads to a pretty interesting question, doesn't it? How will these fundamental tech shifts, like the axial flux motor, becoming more common? How will they not just change how cars perform, but maybe influence the actual shape of cars, our infrastructure needs, maybe even how our cities are laid out in the coming decades?
That's a lot to think about, right? Definitely food for thought. Hopefully this deep dive gave you a really solid, quick understanding of this revolution happening under the hood, so to speak, the kind of tech that's going to be in the EVs that will, soon be everywhere. We hope you had a few aha moments and feel a bit more clued in about the future of electric drive. And hey, if you enjoyed this deep dive, found it useful, maybe give us a like. And subscribing to the channel always helps us out. Also, feel free to drop a comment below if you have thoughts or questions. We'd genuinely love to hear from you.